One of the things I've always wondered about is, could aliens be listening to us watching our TV shows? And if they are, how close do they have to be for us to hear their reply? Now, thinking about that got me down a rabbit hole. Firstly, how many stars are there in the entire galaxy that are close enough to Earth that they would have actually heard our signals? Secondly, how many of those stars are close enough that they could actually send us a reply and we have received that? Thirdly, out of all of those stars, how many of them actually have planets that are potentially habitable? When you map it like that, the first thing we have to answer is, when did we start broadcasting signals? When did Earth start sending messages that people could actually hear? The first ever television signal was broadcast in 1934, and then 2 years later, the Olympics was broadcast in a strong enough signal that someone out in space could have actually heard it. One of the things I struggled with was understanding just how difficult it is to hear things in space. Do you remember back in high school when you would use a basketball and a pin to represent the size difference between the sun and the Earth? Well, this really explains just how difficult it is to hear a signal out in space. Imagine you're this tiny little pinhead. No, imagine you're a speck on this pinhead trying to broadcast whilst this giant ball is screaming that I'm here. If you were to look at our solar system from any of the frequencies, the biggest and brightest thing you would see is our sun. And that's why in radio astronomy, they often have massive dishes so they can collect as much of the signal as possible and hopefully filter out a lot of the background noise. So if an alien was trying to listen to us, they would either need massive antennas or we would need to broadcast with a powerful signal. And that is exactly what we did in 1962. 61 years ago, we broadcast a signal out into the universe saying, we are here from Ukraine. Now, just like any other signal across the electromagnetic spectrum, that signal traveled at the speed of light. Our signal needs to travel at the speed of light, and then they have to reply at the speed of light. When you look at a sphere around the Earth of 31 light years, you only get 16 stars with potentially habitable planets. Now, I don't know about you, but that's a really small number. So let's look at these 16 planets. What are they like? What would it be like to live there? And could we actually visit them? Starting with number 1, Proxima Centauri b. Have you ever seen the scene in Star Wars where there are 2 stars in the sky? It's on a planet called Tatooine. This is probably what it would be like to live on Proxima Centauri b. Although, there would be times where there were 3 stars in the sky. Fans of science fiction will know this system from the book The Three-Body Problem. The Trisolarans lived there and learned to hibernate when there were too many stars in the sky, making it too hot, and they had to dry themselves out to survive. And a little side note there, if you love that book and love exploring mind-bending concepts in science fiction, then it might be worth you checking out this book, A New Eden. A big part of this book is about exploring the galaxy, finding new worlds, and figuring out how you could potentially terraform them. If you like the audiobook of The Three-Body Problem, then the narrator, Luke Daniels, is actually the narrator of this book. Yes, this is my book, and yes, I did get one of the 4 biggest science fiction and fantasy narrators to voice my book. So please, there's a link in the description, go check it out. The next star on our list is Ross 128b. This is the second closest potentially habitable planet to us, and what makes it interesting is it is tidally locked. That means the same side of the planet is always facing its star. Same way our moon is tidally locked to Earth, and its same side is always facing us. The side that was always facing the star would almost be a desert. It would be dry. All the heat would be rising and racing to the other side of the planet. You almost probably couldn't live there. It would always be in the same part of the sky. Going to the other side, it would always be night. It would be cold and dark. It would be like living on Antarctica, but probably worse. The best place to live on that planet would be right in the middle, in between the light and dark side. It would actually be quite temperate. I've always imagined alien life making the most of the light and dark sides. Maybe some alien plant life has a network of roots stretching both sides, and if it ever needs to do photosynthesis, just branches out some leaves on one side, and if it needs to get more nutrients, it goes to the dark side. And unlike Earth, maybe animals don't migrate because of the weather. Maybe some animals that live on the dark side migrate to the hot side to give birth. The next planet on our list is Glyce 1061d. This planet orbits its star in more of an ellipsoid shape. Imagine you just landed on this planet. What you would see is the star coming towards you, then going away. The first time you see it, it would probably be quite scary. Watching this massive ball of fire race towards you throughout the year, it would really put a new meaning to this idea of summer and winter. Number 4, the actual sibling of the last star, Glyce 1061c. What makes this planet interesting is its year is only 7 days. It races around its star. The next star on our list is Latent b. This is what you would consider a super Earth. It is about 2.89 times the mass of Earth, meaning gravity is 2.89 times stronger. This would probably mean that aliens living on the planet would have thicker legs and be lower to the ground. I'm imagining some of these aliens having their bones and exo and endoskeletons not made out of calcium, but made out of something a little bit stronger. Maybe they make use of iron in some sort of way. Number 6. Teegarden 6b. This is the first planet to actually be the size of Earth, so it'll be relatively easy for humans to acclimatize on this planet, assuming it's the same temperature. So once humans have the ability to go out and explore the stars, I propose we go there first, because then we wouldn't have to genetically engineer humans to actually live on a different gravity. Now I'm going to skip over the next 9 on the list until we get to the very last one. Number 16. Glyce 357d. This is a super Earth on steroids. It is 6 times the mass of Earth, meaning it has 6 times the gravity of Earth. That's about the G-force of a Formula 1 driver pushing the brakes hard. Humans can handle that for a little while, but not too long. Living on that would be hard. Unless, of course, you're Goku, in which case you want that to get those gains. Now, to answer the very first question we started with, how many planets are within the habitable zone of their star, and close enough that they could have heard our message and replied with us hearing that? And the answer is 16. Only 16 planets. One of the interesting things I found while doing the research for this is just how many red dwarfs there are. They call those M-type stars. I've heard that they're the most abundant star type in our galaxy, but didn't realize it until I looked at these numbers. Every single star in this first 16 is an M-type star, a red dwarf or a brown dwarf. They're called this because they often shine red and they're really small. Now the next question you might be asking is, are there any stars like our Sun that have a planet in the habitable zone and could have heard any of our broadcasts? We have to go all the way to 635 light years away before we find a star like our Sun that has a planet in the habitable zone. Our star is a G-type star, and so is Kepler 22. It'll be another 500 years before Kepler 22b hears any of our signals, and another 500 after that before we get a reply. That's roughly 1,000 years to go. Just a little side note, if you're wondering how planets and stars get their names, it's because of the naming convention. It goes a little bit like this. The first name is of something significant, usually the telescope that discovered it. The number relates to the order at which this is found. So this was the 22nd star that the Kepler telescope found. And B denotes the order at which the planets were discovered. This is the second planet they discovered rotating around the star. So if you're interested in a little bit more about this, and you're interested in what planets out there are potentially habitable, and what it would take to turn a potentially habitable planet into something that humans could live on, then I honestly suggest you check out this book, A New Eden by Menelik Henry Dyer. It's a little bit like the Bobiverse and Children of Time. If you love these books as much as I do, then I definitely suggest you check out A New Eden. There's a new cover, it's a little bit different from this. And the reason it's different is because I'm no longer self-publishing. So I actually released it online a couple months ago, and it blew up. It got over 100,000 views in a couple of weeks. And so much so that Podium Publishing actually reached out and asked me if I could publish their book through them. Now, if you don't know, Podium first published The Martian, so they know good sci-fi. And honestly, going through the process of editing with them has made my book even stronger. So if you want to support me, get a physical copy, get an ebook, or get the audio book, whatever version you want, the links are all in the description. Thank you for watching. If you would like to watch anything out from me, you can follow either of these 2 links on the screen.